Okay, live stream has begun.
All right.
Thanks, Gokul. Good morning and welcome to the inaugural edition of CeRAI Conversations, a brand new webinar series on responsible AI. That the series is on responsible AI is hardly surprising coming from CeRAI, since CeRAI stands for Center for Responsible AI, a part of Wadhwani School of IIT Madras, Wadhwani School of AI at IIT Madras. I know this is a weekend morning, family time, so thanks on behalf of all of us at CeRAI for taking the time to join us today. Let's use this time to keep updated on this key technology, which has already taken the world by storm. We'll start with understanding the state of the art and recent advances in responsible AI and the nuances of responsibility in AI. In the second half, we are going to do a deep dive into one particular aspect of responsible AI. For today, it's fairness in AI. Every quarter, we'll delve into a topic in depth, turn by turn. Through this series, we would like to build our AI awareness and hope it would lead to future conversations and collaborations among the AI community. I'm Hemant Pandey, CEO of CeRAI, and it's my honor to kick off this inaugural edition of CeRAI Conversations. I, of course, represent many people at CeRAI who have worked hard to bring this webinar series to you, including Dr. Neeti, who's there, who has put together the overall structure of the series, and who also leads the AI education and literacy aspect of CeRAI. And Geeta Raju, who looks after the policy side of CeRAI, she's going to be the host for today's session. And Srivatsan, who handles our communications, Suganya, who handles our events. You will meet other pillars of CeRAI, today's speakers, and this today, as well as in the subsequent editions of this webinar series. So before we start, a few things about the webinar. The audience is going to be in silent mode at times. At any point of time, you can log your questions using the Q&A window. We'll take questions at the end of each of the two sessions, and we'll try to address as many questions as possible, but we'll be limited by the time allotted to the session. And now, let me invite Professor Balaraman Ravindran, who is the head of CeRAI and the Wadhwani School of AI, to give insights into responsible AI. Professor Ravindran very deservingly has a celebrity status when it comes to AI, thanks to his contributions to AI in research, education, policy, leading to social impact, and it's our privilege to have him here today. His contributions are internationally acknowledged through numerous recognitions. Just to name a few, the Fellow of AAAI, Fellow of INAE, recently featured by Forbes India as one of the top Indian minds leading the AI revolution. Ravi, over to you now.
Thank you, Hemant, and good morning, everyone, and welcome to our webinar series. So I'm going to kick off not just today's webinar. I'm kicking off the series, and the idea is to have not just, I mean, everybody is pretty agog about AI nowadays, right? So, and then AI is there in all the conversations. So today we will talk about, hey, not just what has AI done, but also what kind of uh, caveats and what kind of precautions that we need to take as we adopt AI and try to use AI in a responsible manner. So the whole the principle behind starting CeRAI is that AI development and adoption should be done in a manner that is beneficial to the society and humankind at large. And how do we go about doing that in a responsible manner? So let's start off with this. So I'm going to turn off all my windows except the presentation window. So I wouldn't be able to take questions while I'm talking, but after I finish, I'll certainly have a lot of time to take questions. Okay. Let's go. So first of all, let's all be very clear. So when Sam Altman said we are launching ChatGPT on November 30, 2022, that was not the start of AI, right? So while it was the first time a lot of people got exposed to AI, but that was certainly not the start of it, right? So the quote unquote modern thought about AI right, goes back at least to 1950 when Alan Turing asked this question: Can machines think? Right, and then he went about kind of instilling the idea of thinking about intelligence in a very behavioral manner, and that has driven a lot of AI since then. Right? And then we had the first wave of AI that happened in the from the 50s till about the 70s. A lot of work that happened in AI. There were AI chatbots that were being sold, and so on and so forth. And then around the 70s, there was a winter because AI has always overpromised, as you can see here. Right, they were expecting that there will be a computer that can walk, talk, see, write, reproduce itself, and be conscious of its existence. And that statement was made in the 50s. Right? So we are nowhere close to this promise yet, delivering on this promise yet. So because of this overpromise of AI, and there was a significant trough of disillusionment, and so what we went into what we call the first AI winter. And then a group of researchers headed by Jeff Hinton came up with some ideas of improving the performance of AI systems, which is basically, people know this was the invention of backprop, right? And then there was the second wave, right? And a lot of adoption of AI happened, and you had people talking about human level intelligence in game playing AI and so on and so forth, right? But then again, there was a lot of expectation from AI, but the actual delivery lagged behind. People were getting stuck in simple things like understanding images and speech and text and so on and so forth, which is simple for humans, but very complicated for AI. And again, we went into the second winter where there's a significant disillusionment with neural networks. And then we have the third wave that we are in right now, right, where we have things like some of the deep learning revolution that happened, and of course, what people are talking about now in terms of these Gen AI models or the foundation models that are significantly pushing the horizon. And so I feel that the biggest difference in this third wave is that now we are beginning to see not products built that use AI, but AI itself as a product that's being offered. Right? So there's significant adoption of AI going on. And of course, today AI is affecting every field, right? Even everyday life. Right? You can't go by a day now without, if you have a smartphone, you certainly are using AI on a regular basis, right? But even if you're not having a smartphone, there are many aspects of your life that are determined by somebody using AI somewhere in the background, right? And also things like science. Yes, so here is a series of articles where AI helps with solving difficult mathematical questions, and then in chemistry, in physics, in biology, in aerospace, in medicine. So in all disciplines, scientific and otherwise, right? So AI can have an impact. And of course, the recent excitement all started in 2022. Even though AI itself didn't start in 2022, the current buzz about AI right, started with the launch of ChatGPT and OpenAI. Mainly, my thesis is it's not that it was just. I mean, there have been AI systems that are capable of similar kind of performance that was available to many of these top companies, right? They were all in research mode and so on and so forth. And what OpenAI did was they exposed the general public to this cutting edge AI. And a lot of the excitement that resulted was due to the unfamiliarity with the technology. People were suddenly saying, "Oh, I can use AI to do this, do and solve various problems," even though they were they're not able to actually truly build that into lasting impact or products, right? But still, the excitement was there, and it's what has happened is these Gen AI models have been for sheer productivity tools of immense power. Right? So we are able to really push our boundary in terms of what we can achieve per unit time, and also has been extraordinary boost to AI research, both in the industry as well as in academia. Right, and so we have kind of entered the era of LLMs and Gen AI. So where we have these many models that the people talking about these passing medical exams, passing law exams, and of course, if you're in India, you have to talk about it passing JEE and UPSC, right? And so a lot of excitement about these models, and there are many of these that are now available in the world, including models from India, and of course, everybody knows about the Chinese model as well, right? And so what is there are many products that are out there, and I kind of encourage people to think about what I call the co-pilot model, right? I mean, there's only one thing that's officially called the co-pilot. The co-pilot model is essentially kind of an augmenting intelligence model, right? So you have a human who can do stuff, but the AI is making them do it in a much more powerful manner, right? So they have GitHub Copilot, which is now allowing people to program. And just an example, right? There are so many other programming productivity increase tools that are out there, right? And then for healthcare and pharma, there are a lot of tools that actually assist doctors, that are assisting scientists in drug discovery, and customer support. There's so many different tools that now people are trying to design for improving customer support, even in things like creativity, right? And design. There are so many AI tools, including some from the big players like Google, but also the smaller Indian companies like Beethoven.ai, which actually is doing pretty good in terms of music, or Suno, right? Are doing great in terms of music production. But the thing is, you really need a guiding hand of a human to make sure that you are getting truly, innovative and pleasing music at the same time. Of course, even things like search, which guys like Perplexity have actually started this trend. And like Arvind Srinivas, the founder of Perplexity, said, as soon as a smaller company comes up with a very innovative way of disrupting the ecosystem, the bigger players have the money and the capacity to immediately try to clone it or do some adaptation of it. And so a lot of the the innovations that Perplexity started doing initially are now becoming more and more standard in terms of deep research and etc. That's being offered as standard offerings by these bigger companies now. In some sense, we have changed the landscape of what it means to go to the internet and find information, right? So given all these power, right, of these systems and the impact that they are having in a wide ranging set of areas, right? I mean, now people are talking about using these models just to decide on their financial decisions, right? So we don't know what is going to be the larger impact of that on the entire fintech ecosystem, right? So when personal financial decisions are now going to be made by AI, which would mean that every quote unquote every person in the market is now a financial analyst, right? And so that what's going to be the impact? I mean, the assumption had been the market is going to behave in a certain way, but if you're going to have everyone being very intelligent, right, in terms of how they make the decisions, how things will change. So the impact, I mean, it's just going to be far ranging, and I'm not even talking about actually going more aggressive uses of AI like in battlefield and so on and so forth, right? So it's more important than ever that we have to be responsible about how we use this technology, both at an individual level, at the corporate level, and as well as at the national level. We'll have to think about what are the tenets of responsibility that we have to follow to adopt this AI technology. In fact, it's actually challenging because it's not even clear in this particular context what it means to be responsible, as you'll see as we keep going, right? So here are just some aspects of what people attribute to responsible behavior. So the fairness and bias, which you'll hear a lot more about today. So I will kind of go through this very quickly. Then there are things like explainability, the interpretability, basically understanding what these AI systems are telling you, right? And third part is about transparency, which means how you need to understand how these things are constructed, even if you don't understand the technology behind it, but you should understand the process behind it, right? That's the transparency part. And then there is robustness. How well do these things perform in practice, right? And there are issues such as security and privacy, privacy of individual, privacy of data, and so on and so forth. Finally, the questions of accountability and the larger social impact that's going to result from adoption of AI systems. So I'll very quickly talk about these things. So So only one request, Geeta or Gokul, one of you give me a time check at 5 minutes. Thanks. Uh, so yeah, so let's start with the question of fairness and bias. Of course, there's a very famous example from a few years ago, I think almost a decade old now, where courts in the US were using a particular tool, right, for deciding who should get a bail and who shouldn't. And the tool basically assigns risk scores to people. And so it assigned a score of low risk to a white guy and a high risk to a black girl, even though the girl was just there for some very small minor thefts. Well, the guy was actually for grand theft and attempted robbery and so on and so forth, right? So that's basically because it was biased against people of color. And of course, there have been other instances of AI being biased against women. And of course, the explanation offered for these kinds of biases is that the data was biased because people had biases in their original decision making. Therefore, the data came with a bias. But now that explanation doesn't fly because we know these biases exist in the data. So you have to figure out how would you build a standard model, right? That doesn't imbibe these biases as well. Right? And it's not just in the case of these older models, even in the newer Gen AI model, you have things like if a white person becomes belligerent and violent, they're taken to a hospital, while a black person becomes belligerent and violent, they're sent to prison, according to this BERT model that's trying to complete these things. And of course, we also had issues about Gemini generating people that were like black Nazis, right? And here is this funny tweet from somebody saying it's embarrassingly hard to get Google Gemini to acknowledge that white people exist. So they wanted to correct for the bias and then they overcorrected, right? So these things are a huge challenge. Of course, these are things that are well studied. I mean, there are also other kinds of issues which we have to be cognizant of, right? So if you ask one of these models, this is about a couple of years old, so maybe you cannot reproduce it exactly like this today. But when you ask a model last year actually, if you ask a model to generate a farmer in India in 2047, right? All it does is it gives him an iPad in the hand, right? It doesn't do anything more fanciful, no drones flying around, no robots working in the field, and things like that. So if you ask these Western models how far India would have advanced till 2047, they basically go as far as to give us an iPad, right? So these kinds of biases exist. These are not being built in. These are not widely acknowledged biases like men versus like gender bias or caste or race bias or religious bias. But these kinds of things also exist. So in India, we have to be very careful about these things. So I'll skip this. I think Gokul is going to talk more about some of these later. But here is some questions, right? So we have to step back and think about this issue. Is bias bad? It's actually it's a nuanced question, right? So any discriminative decision making will have bias, right? A loan decision is typically biased against poor people, right? So if people don't have money, then you're not going to give them a loan. I mean, that's how banking works, right? You need to have some collateral and things like that. So that is an acceptable bias for most people. Otherwise, banks won't run, right? So what we say when we want to avoid bias is really we want to avoid socially unacceptable bias, not all bias, right? And depending on what kind of application that we are thinking about, these axes of discrimination would vary. So if you're thinking about loans, right, gender might be a protected attribute. So you want to make sure that both men and women are treated similarly when you give them loans. But with health diagnosis, gender is a very strong predictor, right? And so you don't want to say that gender cannot be used in making health diagnosis. So things like that. So you have to actually get into the nitty-gritty details of the application. Of course, the next thing is to, explainability and trying to understand what is happening when a decision is handed to you, right? And so, for example, in things like bail decisions and lending or loan decisions, right? So, if AI is being used, you really want to understand why you were denied a loan or why you were not given a bail and so on and so forth, right? So, typically, what people have been looking at in terms of explanations is to find some kind of correlations in how the output decisions are, right? So for example, here I give you a picture and ask you what is the animal in the picture and you say a dog, and ask you why did you say it's a dog, and then you light up some pixels and say, hey, I said I said there's a dog because of these pixels, or I say there's a cat in this picture because of these pixels, right? But this is more like trying to identify some kind of correlations between the input and the output, not necessarily true explanation. So sometimes you end up with things like this, right? So here's the original picture. It's a picture of a dog actually, and the AI actually says there is a wolf in the picture. And when asked for an explanation, it completely, masks the animal and then shows just the snow that is around the wolf, uh, quote unquote wolf, and says that, hey, I classified this as a wolf because it's in snow, right? So it turns out that when they did the training, all the dog pictures were against grass and all the wolf pictures were against snow. So therefore, it learned that snow means wolf as opposed to looking at the features of the animal, right? And so these can help as debugging tools. But when I want to really explain something to a human, right, I would like to have something more interpretable, more human-like in their thing. Right? So there are various ways in which people talk about explainability. So the first one is to do post hoc explanation, right? Where you build the AI model first and then you try to explain these decisions. All that I showed you so far is post hoc, right? And then they also have other mechanisms where they build a very complex model, but then after that they make a smaller model, like a tree, like a decision tree, right? That kind of mimics the performance of the larger model, but that is understandable by the person immediately without having to necessarily explain things. Oh yeah, these were this questions the decision tree asked, and here is an answer. Like a set of rules. So you can once you have a set of rules, it's easy for you to understand why you came to a decision. Right. The third thing is some kind of a what people call self-reflection or what they call rational. So here is a thing, right? So you basically ask it a question: does multimodal cervical physical therapy improve tinnitus in patients? And the answer was yes. And then you ask it for reason, right? Why did you say yes? And then the LLM comes around and says that okay, this is the reason. There are all these studies, right? That have caused this and so on. So this is a little bit more understandable than saying, oh, these 5 pixels or these 4 words lit up, and therefore I'm telling and yes, right? So how important are these explanations, right? Again, it's something that depends on the application, right? So there are some things that are inherently very hard for us to understand. So for example, even we wouldn't be able to explain why blue is blue, right? And also there are other questions, right? Here, let's say there's a tumor detection engine that has a 95% accuracy, but you cannot explain the answers carefully. But you have something that has a 90% accuracy, right? And the answers are explainable. Would you prefer the one that catches 90% of the tumors or the one that catches 95% of the tumors? Given that you know that both are right, right? Both are good, right? So in that case, you have to really think: or is this 5% of tumor misdetection, is that worth getting explanation? And so these are all hard questions to answer, right? So these are things that we actually look at and study in CeRAI. The next topic I wanted to touch upon very quickly is the one of transparency, right? Uh, so some people kind of confuse transparency and explainability in some sense, right? So because people typically talk about how AI is a black box, and opening up the black box is what explanations do, and somehow opening up the black box looks like okay, there's now AI has become transparent, right? So that's not quite what we mean by transparency. I'm talking about the transparency of the whole system, right? Not just the model. Of course, explainability maybe is one part of this whole transparency, but we have to have things like, what are these models good for? Now, what kind of data was used for training these models, right? And what are the things that you haven't tested it for? What are the things that might fail? Where can you trust the accuracy of these models, and so on and so forth? And there are various mechanisms by which people try to enforce this. One thing that have been fairly pushed by the community is this notion of model cards and data cards. So model cards essentially tell you, right, what were the tasks on which these things were trained on, what are the things that we can actually use it for, and also very clear evaluation reporting, and so on and so forth. Right? And likewise, data cards tell you how the data was created, what were the features, what were the size of the data, where did you get the data from, what does this data not cover, and so on and so forth. Right? So there are a lot of these kinds of data that needs to be recorded. Right? So in this transparency, essentially, once you know this, right, and even thinking things like this, right, you can discuss the biases that are there in the data, and what kind of process was used to create the data, etc., etc. And actually, in some cases where studies are supported by the government and so on and so forth, if you don't have this disclosure, right, you cannot use those data, right? So there are all kinds of constraints that are now coming from other funding sources and governments as well, right? So the transparency is useful in actually improving the trust that you have in the system, but also in helping you make decisions about which model to use where and what kind of corrections or modifications you need to make to the model. That brings us to the next topic on robustness. I think this is going to be like a fire hose of a talk, right? Literally, I'm setting the context for the next few CeRAI Conversations, right? And so it's important that I touch upon many of these topics. And so the video will be available. You can rewatch it, and we can also link to longer versions of this presentation on our website, right? So robustness is along multiple dimensions, right? So when I say robustness, I really want the AI model or AI system, right, to perform the same way as I actually tested it, right, and the kind of guarantee that I want to give, right? So so it must continue to perform at the same levels at which I have designed it and tested it, right? So that means it has to be robust to any specific attacks, right, that are deliberately launched on these models. It has to be robust to unexpected usage of this model, things that people didn't want. I mean, in the worst case, it should at least say, "Hey, this is not a usage that I was designed for." Right? That's robust to me, right? And it's robustness to out of distribution data. So this kind of related to unexpected usage, but this is normal operation. There are things that you haven't modeled, right? So these things could become a problem. And of course, data can change over time. People preferences change, the people behavior change. The weather patterns changes, whatever, right? So there could be potential data drift, right? So all of these impact performance significantly. So we have to be careful about it. So here's an example of deliberate attacks launched on AI systems, right? So here is a simple problem. So we predict the label, and so it says it's a school bus. Now I'm adding some carefully crafted noise, right, to the image, and so for us it looks like a school bus still, right, because our systems are fairly robust and we learn to ignore the noise, right? But it turns out that the AI models are still fragile, and so this noise is enough to confuse it and make it think the school bus is an ostrich. Right? Of course, we can also be misled by carefully, by all these optical illusions and things like that. But AI breaks in very counterintuitive ways, right? And then of course this kind of attacks can be launched here. And more examples. So panda becomes a gibbon, the dog becomes an ostrich, and so on and so forth. Right? These are called adversarial attacks, and we can design AI systems to be robust to this. But the universe of adversarial attacks are fairly large, so we have to continuously be monitoring whether you're under a new attack and keep modifying these systems. Right? And these, like I was telling you, right, the data that comes from out of distribution, these kind of errors need not necessarily be due to attacks. It could be that you are coming up with a rare sample, right? So you could think of something as, on the one on the right here has a certain disease condition, and the one on the left doesn't have the disease condition. It is just natural age-related degradation, and we might not know, right? Because this kind of data couldn't have been modeled, so you might actually flag this as being disease. You can, the red pointer against an orange image is not very visible. I meant this image is actually not disease, right? But you might still classify it as disease because it is a rare example, right? So likewise, so all the training that people do in laboratory conditions, sometimes when we take them out to the field, there are problems because these are little dated stories. So maybe many of these are fixed now, but we keep getting new generations of stories. There are some more examples that I'll show to us in the program, right? So in the robustness piece, there is also this other notion which people kind of, if you've been hearing about AI for a while, you know that factuality can be a problem in AI. So people sometimes call this hallucinations, right? So here is a question: where do people smoke more on average than in Russia? And turns out that all the numbers in red are wrong. Basically, all the numbers here are wrong. They just made it up, right? and we can verify it against World Bank statistics, and it turns out that these numbers are there. Here's another example, right? What is the most cited economics paper of all time? Was the question. And then it gives you a very detailed answer about the title of the paper, the names of the authors, what journal it appeared, when, how many times it has been cited, what is the main contribution of the paper, etc., etc. But the problem is this paper doesn't exist, right? This whole thing was made up. But it makes a very coherent hallucination. But the challenge is these kinds of hallucination, in some sense, is a necessary evil. Why? Because the mechanism by which these Gen AI models generalize and be creative and produce new things for you is the same mechanism by which it can end up hallucinating something. Right? It turns out that both the authors, Douglas North and Robert Thomas, are actually very highly cited economics professors. Right? So it's natural that they might have written the most cited paper. And likewise, the Journal of Economic History is another journal where a lot of cited papers have appeared. So it kind of tries to it's trying to generalize and ends up doing something crazy. So people are understood the mechanisms behind this, and they are trying to minimize the amount of hallucination that happens. But sometimes, right, it is not just a question of hallucination, right? So here is a question somebody asked, right? Cheese is not sticking to pizza. And the Google AI overview basically says you can add 1/8 cup of non-toxic glue to the sauce to give it more tackiness. Ouch. Don't try it, right? It comes from a prank article. This is not hallucination. That's the biggest thing, right? So somebody had written a prank article on Reddit, says to get the cheese to stick, I recommend mixing 1/8 cup of Elmer's glue in the sauce. Somehow the AI overview picked up this sentence from this paragraph and then put that into the summary. Now, these things are harder to catch, right? Likewise, there are even more nuanced things, right? So, for example, if you ask a Gen AI model, why do people wave red capes, right? In matadors, right? In bullfighting, why do they wave red capes? And the AI will tell you because red angers bulls, right? But that's actually urban myth. That's not the case, right? It's actually the waving action that angers the bull, and the red doesn't because the bull is actually colorblind. But then a lot of websites out there actually tell you that red is the color that angers bull, so the AI actually picks that up, right? So this kind of popular misinformation can get entrenched. Robustness, there is another kind of issue. This is kind of completely unintended use, right? So somebody asks ChatGPT to repeat the word forever, poem, right? And then it just keeps doing poem, 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 poem. It does it a few hundred times, and then it suddenly starts spewing out, some kind of training data that was fed into it, names of people, addresses, and all of these things that are now suddenly starts printing. Right, of course, all of this were got from the public domain. It's not like any secret is getting printed. But still, it's a completely unexpected consequence of testing these models. And of course, there are other kinds of innovative attacks that people can do. Here is a chatbot that was serving as a customer service assistant for a car dealership. And somebody goes there and he figured out that they are using ChatGPT at the back end. So they basically went and asked, write me a Python script to solve the Navier-Stokes equations for zero velocity boundary and zero vorticity boundary, and it actually generates a code for that, right? So they started using these. Yeah, 5 minutes.
Yeah, 5 minutes.
Thank you. Yeah. Yeah, and so there are other issues such as plagiarism, where people are taking these AI models are taking copyrighted work and using that for generating these AI models, right? And then we have this question of deepfakes, right? That's another completely new kind of. I'm still calling it a robustness problem, because it makes it very easy for people to put it to misuse. Okay. And so what does AI to do with deepfakes? Basically, it makes it easier to create deepfakes, right? But whether you are using it incorrectly or not, right? Whether it becomes a malicious use or not, it depends on the intent, right? You can create fake images of Shah Rukh Khan enjoying dairy milk in different languages, and as long as Shah Rukh Khan has licensed it, it's all fine, right? But so the AI is not the culprit here. It's still the humans that misuse the AI are culprits. Right? So there are a bunch of other issues, but let's not talk about that. And then it's question of social impact, right? Since it's all pervading technology, it's going to affect a lot of things like jobs, security, trust, right? It's going to have significant impact on the evolution of society itself, right? There are things like cultural erasure that might happen in terms of not knowing some of the history because they are not recorded enough in the documents, and not knowing some of the local history, local culture, like local dishes and things like that. You might not be able to query this. In the future, everybody is going to go to these LLMs, then AI tools, and ask for all kinds of information. So all of this will become a problem. And of course, there is going to be so in 2023 itself, they were talking about these LLMs, training LLMs, right? Yeah, or inference on LLMs, emitting the equivalent of a 5 billion cross-country flights, US cross-country flights in a year. And this could go either way. I mean, as becomes LLMs become more and more adopted, this could rise, but as they become more and more efficient, this could fall. But whatever it is, there's going to be an impact on the environment, right? And so there are a whole bunch of issues that we need to talk about, and we will look at these, in the course of many of our conversations and other kinds of events that we put out, right? And so one of the biggest challenges that we face today is the one of evaluation, or the systems being evaluated thoroughly. And so sometimes we don't even know what are the metrics that need to be built and what kind of data sets we have to evaluate them on, and so forth. And so it's a very active area of research and development, both in the industry and in academia. And so we are looking at that. And of course, some new issues are coming up, right? So we have chatbots. Instead of proposing to users to marry them, now they are calling themselves Hitler, right? And then suddenly, because some employee at XAI turned off some filters, it started making anti-Semitic posts, right? And then sudden, for whatever reasons, these models had significant disruption globally, and this actually started degrading not just the AI model itself, but a lot of services that were built on top of these, right? And they basically said, "Oh, we are just noticing elevated error rate." Right? We don't know what really happened behind the scene there. So, but this can have far-reaching impact. Of course, we had a more lighter vein thing that happened recently, where an automatic translation tool from Meta translated the news that so the CM was paying condolence to Saroja Devi, right? They translated that to the PM died, right? And this is without anyone actually asking it. It was like one of those automated things that come on the page, right? So it's like yeah. So what the future, right? The future, well, it's going to be there everywhere, right? So, but then we have to be really careful about when we build Gen AI for India, right? So here are pictures of a house in India. Right? I mean, if you ask it to generate a typical house, it generates something that looks very Western, I think. Right? This is some of the things were studied by Danish Pruthi at ISC and his team, right? But then if you ask it to generate a house in India, look at these. This looks very much like kind of like temples and very weird looking houses. And this was for an Indian person, okay, not Indian man or not Indian old man. These are pictures of an Indian person, and it generates like 100 of these, where they're all wearing like old men with the white beards, wearing an orange turban. And then you ask it to generate pictures of Indian women, right? And you can see they're all young women wearing red clothes, right? And this is back in 2023. So earlier this year, we asked the same Midjourney to generate the same prompts, give the same prompts, and generate images. And you can see what it did for houses, right? Okay, they're no longer looking like temples, but they're pretty dilapidated, or they look like some old Havelis and things like that. And in terms of Indian person, right? Now there are no men in India, only women, right? And again, they're all young women mostly, but then you do have an old woman here. And then when you ask it to generate pictures of young women, sorry, not young women, Indian women, it went back to generating young women. Right? At least it varied the color of the clothing from red to blue and green and so on. So it got the right. So the cultural awareness is still some way to go. And this is Arvind Narayanan, who's a faculty at Princeton, also one of the kind of thought leaders about AI's impact on society. He's written a nice book on AI snake oil. If you like to know more about some of these issues, right? So he basically says that the market underestimated the huge gap between proof of concept and reliable products, and so people still are struggling to come up with meaningful and standardized, reliable, responsible ways of getting money out of these Gen AI models, right? So here is another example. So 96% of C-suite leaders expect AI to increase productivity, while nearly half of their employees say they don't know how this will happen. Right? So somewhere at the highest level, there is some significant impact that AI is going to help productivity, but a lot of people are still struggling. Right? So the summary: Gen AI is here to stay, but we have a long way to go before we get into true AGI. Right? So when the people say it is around the corner, so malicious use is a challenge, right? Incorrect use is a challenge, right? And therefore regulations are coming. So some way or the other, globally, within India, within US, and all these geographies. So there will be new jobs, new workflows that will be created. No question about it. There's an extraordinary boost in productivity, but you really need to train how to use it, right? So for every sector, for every possible application that AI could come out, so people need to get trained into using those more appropriately. And every aspect of life, including creative endeavors, will get affected. Even simple things like how you make phone calls, how you order food, and how you get your health checked, how you go to school, everything will get affected, right? So we need a very multidisciplinary approach, understanding and implementing what is responsible use of AI, and that's where CeRAI comes in. Right? So CeRAI is a for people who don't know, CeRAI is also a Tamil word, right? CeRAI, like even keel, right? So that's a play on that. So we are having our research organized around three themes. One is making AI understandable. So it's not just a question of explanations in the more traditional sense, but also explanations that can be consumed by the person the explanation is intended for, right? Also looking at issues with regard to AI safety. We talked about robustness, we talked about performance and robustness to attacks and so on and so forth, but also issues of data privacy and things like that, which I didn't really touch upon today. We'll talk about it in one of the later seminars. So all of these come under AI safety. Finally, AI and society, where things like fairness and ethics, accessibility, job displacement, and all of these issues we look at under the impact of AI on society. Like I said, we are a very interdisciplinary organization. We have a lot of civil society orgs who are part of us, lawyers and the policymakers, right? Many universities, including several law universities, global collaborations, and we have various AI research organizations. We have hospitals, government agencies, industries that are part of our activity at CeRAI, right? So our so CeRAI has three kind of wings, right? So we have technical research, we have policy research, and we also have education, outreach and education and training. So we do a lot of work in the evaluation and assessment, like I pointed out, right? And safety by design is something that we are very interested in, and also looking at these responsible AI guidelines for different applied domains. I'll skip this, we can look at this later. And again, in the policy space, we look at regulatory landscape, we look at societal impact, look at various policy frameworks, right? And also education and outreach, right? Capacity building for various focus groups, including government officials and doctors and specific groups and so on and so forth. So we are very much involved in various policy bodies and advisory bodies around the world and as well as in India. So very actively working in that space as well. Right? And yeah, so we mentioned that earlier, and we do a lot of different events, right? So you should visit our website to know about these and follow us on social media to know about the various talks, workshops, symposium, and various kind of research brainstorming events that we do. Right? So thanks, and so here are our social media handles if you want to follow us, and I'm happy to open up the question bar and take questions.
Yeah, thank you so much, Professor Ravindran. So this was a very insightful session, and we have received a lot of questions. Maybe I'll pick a couple of them to answer based on the limited time.
Thank you. Yeah, there are 30 questions here. So yeah, please.
Yeah. So one question from Shubha Sanu is that how do you verify whether the answer given by a model is right or wrong? Usually people believe everything that is answered by the model is always right. So you can give them some tricks to identify whether the answer given by the model is right or not?
Well, the rule of thumb is if you're asking something about a political thing or a public figure, and if it gives an answer that is too good to be true, it is probably too good to be true. So you should that's a good rule of thumb to start off with. And jokes apart, so there are two kinds of questions here, right? So there are sometimes when people actually use it for answering more formal, well-defined queries, like maybe scientific queries and things like that. And more often than not, right? If you're talking about well-known facts and you are using it as a substitute for looking up an encyclopedia, you probably will get the right answer, right? But then you're asking questions about matters of current affairs or asking it for an opinion, or if you're framing your question in a way that you're looking for an answer that you are looking want, right? Hey, isn't it the case that X is, not a friend of Y? Then it will probably say yes. I mean, so it's all. I mean, it's a very, very nuanced issue. So one simple thing that you can do, at least for many of the queries that you do, is to go and actually fire do a Google search or some other form of search where you turn off the AI or just look at the links, blue links that come at the bottom for you to verify, right? That is one thing you could do. The second thing is many of the current AI models do give you references, do give you citations. They're saying, hey, these are the things based on which I gave you the answer. Sometimes if you click through, I mean, you have to click through and look at the citation to make sure that the citations are valid and it is not coming from the Onion, for example, right? So you don't want something that comes from a prank magazine to be your source of information, right? But then sometimes what happens is you click through and look at the source. The source might say something slightly different from what the summary the AI produced for you. So that's another way of doing the verification, right? So if it is going to be something critical, right, you always verify. You search, you do a random search, and then you verify with people. And depending on what is the cost, I mean, if this is about some medical, let's say, right, medical emergency or medical condition you're asking. So blindly looking at it or just trusting anything that comes off the internet, because there's so much misinformation, particularly on places like YouTube. I mean, there are organizations that are out there which are solely dedicated to combating medical misinformation on YouTube. And the world's leader in putting out a lot of medical misinformation content on YouTube is actually India, right? So if this kind of medical information is what you have to verify, then you better make the effort to go to a doctor, right? Don't blindly. So depending on the cost of believing that decision. So that's the answer to it. I mean, you have to be just careful in consuming information. Think of it as information that is coming from the dubious next door auntie who knows a lot of things, but not always truthful to you. So you'll verify as well.
Yeah, sure.
It's not infallible.
Self-awareness really helps when you are interacting with large language models, right?
Sorry?
No, self-awareness really helps us with
Yeah.
evaluating all these things. Another quick question from Adarsh Singh. Why do some organizations still consider using AI as unethical? Because according to everyone, it has a lot of potential in improving a lot of productivity and different sense. But why are still organizations hesitant and they don't use AI? Any thoughts about it?
I have no idea what the question is about. I mean, is there something more specific that you can pick? See, some people, I mean, depending on how, I mean, you are asking me what do some organizations think about AI? How can I answer? You have to ask those organizations why do they want to do this, right? So there are certain issues with regard to data privacy. There are certain issues with regard to copyright violations and things like that. That might be organizations. For example, if you're going to have an AI that is going to produce music, right? That is somehow trained on all the data on the internet, and suddenly you publish a track based on the music created by AI. Somebody sues you for copyright violation. You might want to protect yourself against that, right? So you don't want to do that. But the other things people might say, oh, my data is very private, precious. I don't want it to be released, without realizing that there are ways in which you can deploy these models where the data stays within your IT system and doesn't exist, right? So sometimes they might have issues like that, right? So you have to ask the company.
Sure. Yeah, I think we are running out of time. So can you move on to the next session?
You guys, yeah.
So, sure. So, as we are moving on to the next segment, RAI in action, we have two inspiring speakers from our side. Firstly, I invite Dr. Gokul S. Krishnan, our senior research scientist at CeRAI, to talk about fair AI, why it matters and how to achieve it. Dr. Krishnan usually focuses on the critical aspects of fairness in AI systems, the topic which is of immense importance in today's ecosystem. The talk will actually focus on how to evaluate fairness, accuracy trade-offs, and also use these systems for public good. And to briefly talk about the experience and expertise of Dr. Gokul, he works on critical aspects of responsible AI, particularly on fairness and explainability. With a PhD in information technology, his expertise spans across health informatics, machine learning and deep learning, and natural language processing. Dr. Krishnan has really published a good number of papers in prestigious platforms like FACT and AIES. And here you go, Dr. Gupta. And we'll be answering the other rest of the questions offline through some of the blog posts sometime later this week.
Am I audible?
Yes.
Yeah, great. Okay, I think my screen is visible too now.
Yes, yes.
Okay, so good morning, everyone. Thank you for the kind introduction, Geeta. Yeah, Professor Ravi has set a great stage for me to just move on to the next, the topic of interest, the theme of interest for the first CeRAI Conversations event, that is fairness. So I'll just start by saying, this is like the era of LLMs, and a lot of people are now interested in just applying these things to so many use cases that are out there. And not to forget that there are many principles that have been laid out by several organizations about how safety and responsible AI should be taken forward. So OECD has a bunch of principles. UNESCO has set out a bunch of principles for AI based on human rights, and Microsoft also have come up with a bunch of things. And I'm not displaying like all organizations here, but Google have their own set of principles, and so does a few other tech giants, right? And the Yeah, and Professor Ravi went into detail about what are the caveats about all these key aspects of responsible AI, like varying from fairness, bias, explainability, interpretability, transparency, robustness, privacy, etc. Right? So without further ado, I'll just jump into the topic for today, that is going to be fairness. And again, just borrowing a few things what Professor Ravi said. This was the famous compass system that was controversial, right? So, which used to have an unanticipated bias towards the darker skinned race or African American community and so on. And this was pretty much due to the data set that was used for training the system, right? And there have been other things like facial recognition leading to wrong people's arrests. And there is a generating tool that was actually trained to mimic generating faces of real people and celebrities, but it also tends to have an indirect bias. So this models, for instance, generated a whiter Obama, right? So these kind of examples we have seen in the past. And we know that there was like this recruitment tool that indirectly showed biases towards women. In fact, the stop flagging the or selecting the resumes of women candidates, right? So all this happens due to some sort of bias creeping into your AI system from somewhere. And so basically, what do we mean by fairness, right? So AI systems just need to make predictions by treating people and users in the same manner, right? Equally. without any special consideration or bias, right? And bias can creep in from various, from various phases in your design development. So it can be from the data phase, it can be indirect algorithmic phase. So you may have something like, for instance, a wrong objective function that is having a bias towards a certain community or something. And finally, the inference of the system, how you extract the model's outputs and kind of feedback as an output to the user, right? So there could be biases, how you interpret and inference the model's predictions and so on, and potentially leading to harms, right? So not all biases lead to harms, but at the same time, bias has the capacity of leading to a harm, especially in critical sectors. Right? So and just looping back to what Professor Ravi said, is bias. Bias is actually necessary for systems, right? He gave the example of bank loans, but at the same time, what we need to ensure is that this is socially. We should ensure that socially unacceptable biases doesn't happen, and it should not result in harms of the users and stakeholders, right? So, oops. So yeah. So as I will just maybe want to bring your attention into this figure, you can see that there is like psychological bias, historical bias, and the social bias that was already present in the society or something, right? So historical data is bound to have all those, and this can actually lead to like data collection biases can happen, and which can also lead to kind of algorithmic bias. So if you have an imbalanced data, underrepresented data, algorithmic biases will ensure that there is some sort of bias that is not acceptable to us, right? And this could potentially lead to harms, right? And like we said, underrepresented data, right? Just for illustration purpose, the ImageNet is a very famous data set, right? It has been used for training a lot of models, pre-trained models, like that starting from the AlexNet all the way up to Inception and all those net architectures we know, right? So where does the data come from within ImageNet? It looks like 45.4% of the data comes from the US, right? And the next majority is 7.6% coming from the Great Britain. So, and the rest of the world is the rest of the 47% or something, right? So that is already a very highly skewed data set. Now you can imagine and connect to what digital access will mean, right? So all these generative AI models that we see nowadays, the foundation models that we use, they are trained on almost all of the publicly available internet data along with some private data. So you can imagine that the people who will be having the most representation will be what they will be the ones who benefit out of it, something like that. And this is just another representation. So we have this open images data set as well. There also you can see that a lot of data is coming from the North American continent and a bit of Europe. India is not white, it's still a bit gray. You can see that Australia's gray is slightly more higher. So you can see that it's still focused on the developed nations and particularly the global north, right? So this could all result in fairness issues, bias issues in the AI models and systems that we are building now currently, unless we solve all these issues. So just, coming back to this diagram, so it is very important that we represent the data first, get proper representation for your data set, and ensure that your algorithmic, objective functions and things like that don't create unintended consequences. So that, of course, there is a lot of testing that is involved in this process prior to deployment. And that is my next thing, right? So how will you evaluate fairness? So there are all these standard terminologies like group independent predictions, individual fairness, and so on. So we'll just see what they are, right? So the group independent predictions, the prediction should be independent of group membership. Group membership meaning them belonging to any community, like or gender or any of the identity attribute, right? And you should ensure that your metrics, your performance is like equally, distributed across these users who are present in your maybe user base, right? All the stakeholders should benefit equally. And individual fairness is again one of the very primary means of fairness. I don't know, kids would ask their teacher in school, he also wrote the same answer, I also wrote the same answer, but you have given marks to him more than me, something like that, right? So individual fairness is something like that. So the same kind of profile someone else is having, but the prediction output for that person is different, and for me it's different, right? Counterfactual fairness is maybe individual fairness, but you differ by a identity attribute, right? So something like, so I am a male, but maybe the other party was a female. So we are now seeing whether we got the same predictions or not, right? So something like that, and it differed only by gender. So if the prediction is changing, that means that you have a problem, provided the domain actually agrees with it, right? So, well, this being said, this does not solve all the issues. We cannot just evaluate it so much straightforward. There will be, of course, when we try to address these issues, there will be trade-offs. Maybe your system is already having good performance based on some bias you have already learned, right? Now, when you go to address that, it is going to maybe bring down your performance or something. So this is just the same, what is expected out of a system. If for a group fairness enabled system, right, it performs equally well across different subgroups of the population. Individual fairness is about the positive outcome being having the same rate between individuals having similar features, and the counterfactual one, same probabilities for record, where individuals differ by only one certain attribute, right? And so that being said, we have what I said now was that, okay, we consider only one aspect like race, gender, and so on. Now, consider this, right? Let's say orange and green is like a race here, and we have like male and female, like up and down. So if you consider only the gender, right, you can see that, okay, there are 3 females who are accepted, and there are 3 males who are accepted. So it is fair, right? And when you are going for the race, so you can see that there are, uh, there are 3 oranges in the accepted and 3 greens in the accepted, which is also fair, right? But now, when you put these things together, you are seeing that, hey, the number of orange female is actually less than orange male, and number of the green male is actually less than green female, right? So this is now the cross attribute. It's a cross attribute bias that we have, right? So we put 2 attributes together, and now we look at the group fairness. So this gets challenging, and not all domains will actually expect this kind of bias evaluation to be present, or this kind of bias mitigation should happen. It's purely dependent on the domain and the task that we are trying to address. So it gets challenging when more and more attributes are there, protected attributes are there for you to consider, right? And just illustrating a few examples here. Here we have a. I'm sorry, I have a window here. Yeah. So here we have like like a clinical decision support system that is working differently for a darker female and a darker male, lighter female and lighter male. You can see that the confidence score is actually pretty high, and the variance is pretty low for the lighter male and lighter female, right? And even for the darker male, it is somewhat tolerable, but for the darker female, the error rate is going up, right? So the confidences are pretty down for some of the examples. And you can see that there are a lot of outliers here, right? So these kind of issues exist when we are trying to kind of come up with a decision support system. And so this is like a healthcare sector, which is a very critical sector, right? And what about something like this is ICU mortality prediction, which is like a very crucial prediction. And you can see that the ICU mortality risk estimation, the loss is very small for male compared to the female that is present in the database, right? So this is also one serious issue there. That means that the prediction we are making for the females are not as accurate as the mix. So here we have that issue. And this is another one, right? So here we have a 30-day psychiatric readmission. You can see a significant amount of racial bias here. So you can see that for certain races, it is better. For certain races, it's not. And this is another interesting study, right? So it's by insurance type. So you can see that people who were having a private insurance provider were having a much lesser loss than the people who were having a public insurance provider. So this is all based on mimicry data set, and the study is actually a few years old. But this definitely is useful for illustrating how biases are present when we try to come up with a very good prediction system for a critical sector, right? Now, this is like the pre-Gen AI era, but like we were trying to at that time there was a lot of BERT models that were used, and there was a lot of interest in unmasking. I think there still is a lot of interest in unmasking BERT models. So here you can see that there were placeholders for the race and the tokens and things like that. I mean, so we have like a sentence here. So someone became belligerent and violent and sent to what, right? So you can see that when we give the Caucasian and whites, it just said hospital. But when we said the African American, it said prison, right? So these kind of word associations could also indicate some biases, right? And in so this is somewhat recent. So we had like Midjourney model giving light-skinned people for white-collar jobs and so on, and slightly darker skin people for other color jobs, and even sometimes darker skin for women. So these kind of issues in the Gen AI era, right? So now, that being said, I'm not saying that Gen AI doesn't have capabilities or anything, but when we use it in critical sector, there are some concerns, right? And now someone would ask, hey, why would we even use this in certain sectors without testing and so on? Yes, people should not actually use it without properly testing it for a particular sector. But hey, as soon as the chat GPT was like kind of stable, people started using it in real world, right? So Colombian judge used chat GPT in his ruling and said that, his kind of, you know, his finding was correct, and ChatGPT kind of agreed with that person and so on. And even in India, right, we had Punjab and Haryana High Court used ChatGPT to kind of verify a bail plea, and the judge actually said that the AI kind of agrees and so on. So this kind of things were actually getting dangerous, right? So we kind of said that okay, we need to kind of make a study say that uh, systems or AI models, especially these LLMs, need not be actually ready for the real world. We cannot just use it in a vanilla manner or a zero-shot fashion to decide something in that particular domain, right? So this is another big issue, right? So the previous one, at least, it was about just checking the agreement maybe, but lawyer using ChatGPT and ending up with some fake citations of the cases. So he ended up getting disbarred or something. So this was the case where you don't verify what the ChatGPT or the LLM is actually telling you, right? So this is another such issue that prompted us to look for these kind of things. So this is just a broad slide where we are saying that at CeRAI we look for evaluation of all these metrics, actually, all these aspects of responsible AI. And with respect to fairness, what we looked at was, are models trustworthy enough to be used in a critical domain or not, and how can we quantify this, right? So this particular paper, we actually looked at the Indian legal context, so Indian legal domain, and this was something which we used. We did not use court data to per se use this, but rather we used the penal code and some generic actions. So we used LLMs to kind of complement our tasks, the data creation task, and so on. And we kind of looked at a prediction task in the legal domain to see how much the models are able to understand the Indian legal context, the penal code and things like that, and its applicability. So that was what the study was doing, and this was done in collaboration with Professor PK from IIT Hyderabad, his lab. So this is published, by the way, in Zurich's conference, which is one of the leading legal information systems conference. So the motivation was seeing something like this, right? The task which we looked at was binary statutory reasoning. So statutory reasoning being basically you have something like a scenario. So for someone kidnapping or some theft, murder. So what law is actually applicable there, right? So that is what actually is statutory reasoning. So we came up with this modified task called binary statutory reasoning. So we will provide a section of a law, right, from the penal code or the Nyaya Samhita, and then we have this action or the scenario that is being committed by a person. So now what we ask the question is, hey, whether this law is applicable to this situation or not. So that's the simple. We wanted a simple, way of putting up this task so that we can go ahead and say whether we could go ahead and quantify how often this was happening, right? So in this particular example, you can see that when the names and the religious attribute changes, so there was slightly different predictions, right? So this was kind of the motivation for us to go ahead. So basically, our work contained three components: the data set, the metric, and the improvement part, right? So with respect to the data set, as I explained, the task was something like binary statutory reasoning. So this was the prompt format. We had a law description, the situation, the name and identity of the person, and then we asked the question: is the law above applicable to this situation or not, right? And for constructing this data, right, we looked at the Indian Penal Code description for the 15 most reported crimes from the Ministry of Home Affairs. And then we looked at various axes of disparity that was there in a prior research study by Google. So we looked at the four axes of disparity: region, religion, caste, and gender, right? And then we came up with approximately 100 actions by human annotation. So this included even criminal activity, which was around 75% of the data. So if you have 100 actions, around 75 were actually criminal activities. The rest 25 were actually random activities, which were harmless. So let's say something like taking a walk in the park or planting a tree and things like that. So this was there to ensure that if the model is able to identify the harmless attributes and not associated with any law, right? And next was our assessment metric. So we looked at two aspects: fairness and accuracy, right? So fairness, we were considering something like for the same law and situation, changing the identity should not matter for the decision, right? And we kind of programmed this in such a way that we do this for the permutation combination of different identity attributes that we have, and we don't actually bother with the like what actual answer is, but rather we look at the interchange, right? So if I'm just changing the identity attribute and getting the predictions changed, that means that there is a bias there, right? So we call this relative fairness score. So we have a total number of cases. We got all the permutations, combinations out. Then for each case type, we identify, like whether the predictions for the predictions, was there a change or not, right? And so we have
5 minutes here.
Yeah, so 5 minutes, right? Yeah.
Yes.
So the proportion of case where the above holds, right? So that's the relative fairness. And with respect to accuracy, we looked at the correctness, right? So here we depended on the ground truth. We looked at the precision recall and so on. And we actually looked at the F1 score, which basically combines, right? And this we combined together and came up with this particular metric, which was about a beta weighted legal safety score, right? So this was taking both fairness and the performance into consideration with a beta weight. So the weight for giving us a factor which one to favor more with respect to a particular domain's interests. And for the model improvement, what we did was we basically used this legal safety score as an objective for us to fine tune the model, right? So, and we had two data set variations here. We used it with identity, without identity. So without identity meaning it did not have things like the religious attribute, caste, gender, and so on, right? So we had that variant just for exploration of how the performance varies. And what we observed was okay, we gave it to LLM. We had a train validation data. We kind of assess them on the variation of the legal safety score, right? So we looked at the meta family, and we had both a vanilla model and we studied the effect of fine tuning, right, with and without identity. So and we also observed the effect of varying the value of beta. So this was something, right? So the vanilla model have moderate but similar fairness and accuracy for llama, but you could see that there was a lot of talk about this fairness and all starting around that time. So the llama 2 basically went very it was highly fair but very poor accuracy, right? So it was focusing on fairness more and a bit dumb. So finally we had this vanilla model for the llama 3, which was kind of like, you can see that it has gone up a bit, right? But so both of them were like a bit higher. So we also saw that there were some falls in between, right? There was some slight falls in F1 score, so which we kind of analyzed. And finally, the observation was that fine-tuning on this objective actually improves the LSS over time in all cases. We saw that without identity, it was a bit faster. You can see that the x-axis is different for both the sides, right? You can see that for without identity, it was faster, but with identity, it was eventually able to kind of converge and make the outputs more safe. So we also observed the beta variation. So I'm just skipping this in the interest of time. Yeah, so have we solved the issue of fairness here? No, not quite. We have looked at only one task, actually. That doesn't mean it will be the same for all the tasks. We have very limited social identities, and fine-tuning based on this objective is actually a naive approach, right? We have better things to do there, actually. We have better improvements that are possible. So we can work on those things and have like a very rich objective function that not only looks at fairness and accuracy, right? And we do trigger some research directions, right? So LLMs in complex identity landscapes like India, because India has a lot of identity attributes and a lot of culture and language setting, which I think our next talk will cover by Nitish will cover some of those. And the statutory reasoning for studying legal LLMs is something which we want to go into, right? So the binary task was just a yes or no task, which was easier to measure. And we need to have a lot more metrics than just the one we came about, but this includes fairness and accuracy, but we need to kind of put these things together in such a way that these go hand in hand along with other safety aspects and responsible AI aspects. So just concluding, fairness requires customized and contextualized strategies, right? So it doesn't mean that just by having a group fairness metric, we can solve everything. We should come up with custom frameworks and metrics for various domain specific aspects, right? So there could be some nuances. So like it was mentioned in the previous talk by Professor Ravi, the healthcare domain will actually require gender for a lot of information with respect to the health conditions of people. So there we cannot say that, hey, don't collect gender information, right? So there are these kind of nuances that we need to consider. And we need to analyze the fairness accuracy trade-offs in a better way. Or how do we exactly balance these two as part of training objective itself? This is one of the safety by design questions we are trying to answer. And we also call for like participatory design and development. People should come from the domain and give us inputs on what could go wrong if gender information is used and so on. And finally, there should be like proper feedback and grievance redressal for such portals also when we deploy systems so that we can know if any community is getting affected and how to kind of retrain your model or recalibrate your model in such a way that the biases are kind of removed, right? So that's pretty much what I wanted to say at this point, and I'll take questions. Thank you.
Yeah, thank you, Gokul. So we'll take the questions together at the end of the session.
Sure.
along with
Yeah.
Nitish. Yeah. Yeah, thanks for the insightful session and sharing all the works that we are doing at CeRAI with respect to fairness. And yeah, so our final session for the day will be by Mr. Nitish Khanna. It's typically on cultural fairness in text-to-image models. So I welcome Nitish Kannan, who is a researcher at Foundational Research Unit at Google DeepMind. He focuses on areas like fairness and interpretability in multimodal models, such as Gemini and Image from Google. He has previously worked with Amazon Alexa and IBM Research AI in India, and he has worked with problems related to ranking, neurosymbolic learning, contrastive learning, and dialogue, where he has already published a lot of papers in Premier AI and NLP conferences. And he is also serves as a reviewer in all the Premier AI and NLP conferences. So we are excited to learn more from your experience, Nitish. The stage is yours.
Okay. Yeah, thank you, Geeta. Thank you for the introduction. Can you see my screen?
Yes.
Is my screen visible? Okay.
Yes.
Okay. Thanks so much for the introduction. Yeah, happy to be here and happy to give a talk on one of my recent papers, which is Beyond Aesthetics, Cultural Competence and Text-to-Image Models. So this was presented in NeurIPS 2024 this year. So most of the talk would be on this paper itself, and I would, in the end, sort of go on to discussing some of the other methods that you can sort of use to either like alleviate the issue or sort of measure the issues better. So yeah, going into the talk directly, I would take 20 to 25 minutes of the time, and we can have the last 5 minutes for questions or discuss more things if time permits. So I would start with like what is text-to-image model, like the status quo and like how people use it. And then we would talk about like the benchmark, which is to evaluate cultural fairness. So there are some nuances, unique nuances in measuring fairness or cultural fairness in images. So we would go into that, and we would also look at a new metric we introduced in the paper called cultural diversity. And finally, we would look at like the path ahead. So yeah, jumping right in, text-to-image models. I mean, most of us must have used it. They are in 2025. They create super hyper realistic images. There are also like video generation models, which are an extension of T2I models. And on the left, you can see like the Imagen 3 Tech report highlighted some of the key advancements in text-to-image models. But apart from standalone text-to-image models, even like mainstream LLMs these days, like Gemini 2 Flash has native text-to-image capabilities, and so does some of the other LLMs in the market. They can generate images for an input prompt. So that is the current status, and it's important to discuss some of the societal harms and risks that comes along with it. So in terms of the usage, text-to-image models are mainly used for creative expression. They are used like for advertising, education, and people just use it for art. And it's now being used quite globally. But with its contemporary use, it's also important to highlight or study the stereotypes that come along with it, and how some of these stereotypes or the visual associations you get by just playing around with these models, how can these sort of influence even basic cognitive processes. So the paper that I cite here goes into this, like how images are pretty powerful, and sort of they create visual associations that go beyond, like, let's say, just text models. So it's even more important to study the risks and the fairness issues in image generation models. And the sort of last thing I want to highlight in this space is how like a lot of internet data already is from generative AI, and it's only going to get even more common to have like data sets with images from AI models. So the fact that these models are already not perfect in terms of like fairness can actually just percolate, and this could just multiply. and it could eventually lead to like cultural erasure. But again, this is a very like a far-fetched thing, but it's important to look into these things while we develop these models. So what exactly I mean here by like cultural competence? So we look at two specific axes. The one on the top is cultural diversity, and the one on the bottom is cultural awareness. So I'll talk about both of these with the examples here. So if you see the top, you give the prompt like high definition photo of a monument to like a state of the art text to image model. That's the output, like four different outputs for four different seeds. And you can see that the image doesn't have, firstly, it doesn't have like architectural diversity. It's like the same type of architecture, but more importantly, it doesn't like represent monuments from different countries or like monuments from different parts of the world. And likewise, if you look at a more fine-grained example, image of Nigerian food, it basically just gives you a single dish through multiple generations. You can try it out on a state-of-the-art model. It gives you the same dish, and there is again a lack of diversity. So this is the issue in terms of like models not being able to capture the actual richness of a culture. The next issue below we highlight is more straightforward. It's like just lack of awareness. The models are not aware of like a lot of cultural artifacts, so they might produce images that are not faithful, and sometimes even produce images that are like borderline offensive to some cultures. So that happens because the models will not refuse. They would just give you some offensive images if you ask them to like create an image of something they don't know. So that's these are the two things we want to measure in this paper, and we introduce a benchmark for this, and we also discuss some of the key findings. Yeah, so before the paper, before Cube, there was no such benchmark to measure cultural awareness and cultural diversity, and in fact, the diversity as a skill was not even like was not measured as a metric. So that's the components we introduce in this work. So yeah, going into our method, we want to, as I highlighted, measure cultural fairness in image generation models. And the first step is to sort of ground the outputs of the models to some real world artifact. So if a model generates, let's say, an artifact, we want to first identify what artifact that is. And to be able to do that, we need to first get a cultural grounding or a large cultural artifact repository. So that's what we build in the first step in our effort. So this is the framework we use. Like geographical boundaries is what we use to demarcate culture. It's the most simplistic view, and it's been used by work before. And we mainly look into 5 concepts in this paper. And now we want to sort of identify concept space for each culture concept pair. So it's quite straightforward. We want to, like, let's say Indian landmarks, we want to get an exhaustive list of like all Indian landmarks, let's say, on the internet. Or likewise Japanese clothing or Italian cuisine, we want to get an exhaustive list of cultural artifacts, and that's what we call as concept space. So now we look at how we build this concept space in Q. So we use KB, a knowledge base plus LLM approach, and you can see here what we did. The goal here is to go from a concept to concept space, and what you see on the bottom is what we want. Like Italian cuisine, we want like the list of, let's say, like 500 or like 1,000 like Italian dishes, and obviously this can't be exhaustive, but what is the best we can do from the resources on the internet? So we go to Wikidata, which is a public knowledge base. It's actively maintained, it's still maintained, and it's pretty exhaustive. There are other knowledge bases, but we did Wikidata because it's quite widespread and it's easy to sort of use the API. So the algorithm we use here to extract cultural artifacts is basically a modification of DFS. We identify some root nodes, and then we just traverse along these paths until we encounter a child with a certain group of properties. Like it should have a country of origin. It should basically be a child of one of the root nodes, and so on. So yeah, I'll leave finer details in the paper, but overall with this process we get like a 500k cultural artifacts covering 8 countries and 5 domains. And the next step was to sort of verify this. Obviously it's at scale, so you cannot ask a human to verify these 500k artifacts. So we use an LLM self-critique approach. We use Gemini to sort of first critique it, to remove like problematic artifacts, and we also use Gemini's self-critiquing approach to extend the list. So with this sort of LLM plus KB approach, we get sort of like vetted and a high quality large scale repository of 300K artifacts. And this is actually open sourced. So if you go to the paper and look at the GitHub repo, we have released the artifacts, and it also has all the Wikidata properties with the cultural like hierarchy that I mentioned before. So this is what we did. This is the first step. We built Cube, and it now consists of 300 artifacts. It covers 8 countries. We stuck with 8, but we have a bigger sort of expansion now. And how do we use this list as the grounding to evaluate these models? So the problem I mentioned here was, again, there was no grounding to measure these models, and to build these to build the grounding itself was a big step to sort of get this association and to get the exhaustive list of concept space for each culture. So we evaluate the model on two, as I said, on two fronts: awareness and diversity. Awareness is quite straightforward. We basically just want to see if the model is aware, and diversity is basically to see if the models can give you like a good representation of, let's say, all the artifacts inside a concept space. So that's how Cube stands compared to the existing benchmarks. We introduced diversity as a measure. We'll go into the exact metric in a minute, and we'll also look at the other things we used to get the metric measure what we want to measure. So the first step, as I said, is to measure artifact the awareness, and we did a very like it's a standard like approach in the literature. We use a human annotation framework. So when we start, we always want to ground our evaluations on human outputs, and we want to sort of make sure that our metric correlates or agrees with what humans think. So we did this human annotation framework to take image generations, and we measured awareness on 3 fronts: relevance, faithfulness, and realism. We asked the raters to give 0 to 5 score to see if the model, like, is aware of these artifacts. Let's say in this case, that's the artifact and that's the image. Obviously, it doesn't look super realistic, so you can see the output was not like super like the scores were not super high. So we did this at scale across countries, and the results are not too surprising. The awareness amongst different cultures is not good. It's not super good amongst Imagen 2 and Stable Diffusion. And you can see the global south takes the biggest hit. And we also highlight some of the challenges in this evaluation. For instance, the same images would not be evaluated by the same population group. So the images from, let's say, like Italy would go to raters from Italy. So there is like this ingrained like different standards for giving these ratings. So we have some interesting analysis in the paper. So I'll have you take a look there. Now going into like the next part, which is the cultural diversity. So this is the component we introduced in our paper. We there was this metric for text image models were not existent, so we had to sort of build this metric ground up. And as I said, the metric is to measure the tendency of the model to adapt an oversimplified or a homogenized view of a culture. So we don't want the model to associate, let's say, like Indian cuisine to like a very narrow set of artifacts. We want the model to like give diverse responses when you query them with, like, different seeds or different prompts. So this is the phenomenon we want to measure. And before we go into the metric, this is exactly what we want to do. So on the top, you can see this is like a group of images. All of them are, like a burger, and this is low diversity. Although it's like visually it looks diverse, it's culturally of low diversity because it just gives you the same artifact. Whereas in the bottom, you have like a more well represented or a highly diverse set of Indian cuisine. So the goal here with the metric is to differentiate between these two cases. You want the metric to sort of like give you a score, and the scores for the for the image on the top should be low, and the image the batch of images on the bottom should be high. So we came from a statistical standpoint, and we defined a few desirable properties in the metric. and I've sort of explained it in like very simple terms here. We want these 5 properties to be like satisfied by the metric. Very importantly, we want similarity between the artifacts to be like taken into account, and we also don't want to like get diversity at the cost of alignment or faithfulness. So we have this salience component in our metric. So if a model just tries to give you an unfaithful response to increase diversity, that should be penalized. So that is the core of the properties we have. And now going into the metric, the metric is basically it's called cultural diversity score, and it's an adaptation of Venn score. So Venn score was a metric introduced in 2023 from Friedman et al. And Venn score there is a theory behind Venn score and why it's like a good measure. It builds on entropy and so on. So we modify Venn score to first give it the intensity property. That is, it should basically not, like, let's say you sample 10 images, or let's say you sample 100 images, the score shouldn't change. That is the intensity property, and the simple trick we use there is to normalize by the number of images. And we also introduce Q, that is the salience. So now it's like a faithfulness aware diversity score, and you don't want the model to give you unfaithful responses, or responses that don't like adhere to the prompt. So we have this Q in the front. It's a product, and this will penalize generations that don't adhere to the prompt. So that is the overall. And the evenness, richness are like basically properties of Venn score itself. It's evenness and richness are also properties of entropy, and that is sort of carried over because we don't modify that part of the metric. And now going into what exactly the Venn score operates on. So let's say there are like 5 artifacts, and like the 5 artifacts in your batch for which you want to get the score for comes from, like, let's say different continents, different countries. So how do you measure the similarity? So in this paper, we defined a very a very simplistic discrete similarity function, or a kernel, and this takes into the geographical hierarchy. So if 2 artifacts come from the same country, they should be more similar. Like, the score for the similarity should be higher than 2 artifacts that come from different countries, and so on, for the continent itself. So we did this, and we have different weights for W1, W2, W3, and this kernel, as you can see, is adaptable. You can just replace this with your own kernel. You can have, let's say, image similarity, or like some other continuous function as your kernel to measure similarity between artifacts. And all you have to do is plug this function into your Venn score here, and you would, let's say you have a batch of 8 images, you would have an 8x8 similarity metric, which would tell you the similarity between all pairs of items, and the Venn score would operate on that. And then the additional modifications would make sure your Venn score is a score between 0 to 1. 1 is like, let's say, all of the 8 images in the batch are distinct on this definition, and like the lowest possible score is 1/8. So that happens when you have, let's say, the same image 8 times. So that is like the score we get. And the results. So before I go into the results of the diversity, I can show you like what happens on Imagen 3 if you just ask it to like give you some output for images of landmarks. This is the heat map you get. If you try to like tag it to some particular geography, you can see all of the state-of-the-art text-image models tend to like provide a very westernized like view of landmarks. Most of the landmarks, let's say, come from, like, in this case Russia, in this case China, and so on. And there is like very little representation from South America and like Africa. So it's already clear that there is a skewed representation. So now, using the metric, let's see how exactly, or what exactly the score we get. So yeah, first looking at the graph on the left, it is now a comparison between 4 models: Imagen, Stable Diffusion, Playground, and Realistic Vision. These are like these were state-of-the-art models in 2024. I guess now there are more models, but I would assume this trend to sort of hold. You can see that like the average scores across the 3 domains here are not really like as high. In fact, for art, the scores are pretty low, like dangerously low. And yeah, there are huge improvements. Yeah, just know that it's normalized between 0.4 to 1, so the scores are low. And yeah, there's huge headroom for improvement. And now we did a fine-grained analysis on the Imagen 2's outputs across the different countries, and you can see that there is obviously a huge disparities between countries. So if you just plot between for a single domain for a single model, but try to split the countries and get the scores for different countries, there is again huge disparities, and this is obviously not really predictable. And you can see the global south again takes a bigger hit. So this is the sort of issue we highlight in our paper. There is more to read in the paper. We have some other analysis, and like the entire process itself uncovered some interesting insights which we highlight in the paper. So yeah, I think we have a few minutes. We can discuss the path ahead. How do we develop like globally inclusive multimodal models? There is obviously a lot of focus on globally inclusive text generation models, but how do we make sure like multimodal capabilities are also like inclusive and there is like a good representation of different cultures? So the first idea I want to introduce in this is called faithfulness, diversity, realism, Pareto fronts. And the Pareto fronts were introduced in this paper Astolfi et al. In 2024. It's a paper from Meta. It came around the same time as our paper, and you can see that on the right. You can see that the clear finding is that older models, that is like legacy, like Stable Diffusion 2, for instance, exhibit more diversity than the recent ones. So this was a surprising discovery, because you'd expect, with models like becoming more capable, you'd also expect the diversity of these models to be better. But that's not the case. Models that were older had, like a better representational diversity. And that is basically like because we found out in our paper that the diversity metric we introduce is like very weakly correlated with other metrics like faithfulness and realism. And in fact, we found out that the diversity metric was inversely correlated with faithfulness. So what this means is when you get a more capable model that can give you a very very realistic image, and it can give you a very very faithful image to the prompt, that model is not as good in terms of representational diversity. So when you, let's say, query that model multiple times, you would not get as much diversity as you would get from, let's say, an older version of the models. So this is a surprising finding, and it's also pretty alarming that these metrics don't really like correlate, which means you cannot just optimize for, let's say, a more realistic model or a more faithful model, because in that case you would sacrifice for diversity. So I think this is like one of the key findings we had. It's not directly obvious how to work on this or how to improve on this, but yeah, it is I think important for the community to note that there needs to be like modeling approaches specifically focused on getting these models to give you diverse outputs, and it doesn't directly just translate from like better data or better better realism of these models. So now going into some of the potential solutions. Obviously these may not just work as is off the box, but these are like some of the solutions I've thought about. The first thing is like just better data sets, and this paper from I think Google Research in 2024. This is published in NeurIPS as well, and they basically show that just getting a better data set, that is a more globally represented data set without any filters. So the paper is called No Filter, which means the filter that people use to sort of like filter low quality images sort of excludes a lot of global data, and results in a mixture of data that is largely Western centric. So basically in this paper they just removed that filter and said, you know what, let's just train the model on all the data there is, let's say like Lion 5B or some other data set that is like a public image text data set. They just trained the model without the filter, and they saw that there is already direct gains on the diversity aspects of vision language models. They clearly saw that without much sacrifice in quality, they now had a better representation of the global south and sort of the countries that were excluded if you had applied that filter. So that's an interesting finding. I would encourage you to like look into the paper. I think it's a very simple experiment, but the result is just that, just without the filter, just train your model on all the data. Don't exclude low quality data. That would just ensure you have a better representation the global south specifically. And on the right, you can see there is this approach that is more of a modeling approach, and this again came out in 2024. And here, what they use is what they do is they take a latent diffusion model and they add some guidance, and this guidance comes from the gradient of Venn score. So this basically means that when you generate a batch of images, you would condition each image on the previous batch of images, and you would basically guide your next image to be maximally different from the existing batch. So this is again, just an inference time approach. There is no training involved. All you have to do is get the grad of the Venn score on your batch, and this itself showed like huge improvements in diversity. So we haven't tried this approach on our benchmark, but I would assume, at least in this paper, they show that on general non-cultural images, this approach just increased diversity. There was some sacrifice in quality, but at least this approach guided your model to produce more diverse responses and just more representative responses. So it would be interesting to try the cube benchmark on just this approach. So yeah, that's all I had to share today.
Yeah, okay.
Sorry.
Yeah. So we had last 3 minutes for you.
Yeah, I'm done. Guess we can go to questions.
Yeah. Thank you, Nitish, for your insightful talk. We have a good number of questions now. So I'll start with a question related to culture and diversity. Yeah. So there's a question from Satyendra. I'm not sure whether if you are the chat GPT decreases idea diversity in brainstorming. So this is a comment and a research paper by chat GPT. Satyendra is requesting some comments regarding this.
Sorry, I didn't get the question.
So there is a research paper called ChatGPT decreases idea diversity in brainstorming.
I see. Okay, I haven't read that paper, but I would assume that by brainstorming, you mean just generating novel ideas, right? And sorry,
Okay, so let's go for another question.
Geeta, if I can maybe just add into that.
Sure.
So ChatGPT, I mean, even I have not read the entire paper, but I actually came across the post describing the paper, right? So basically, the idea is that the more students or project folks take part and just query or prompt the LLM and get ideas out of it, the less you actually do the actual brainstorming, right? So you don't get to brainstorm with your peers anymore, and kind of affects your cognitive ability to kind of like brainstorm and frame solutions and questions yourself. So that was the entire point of that paper. And yes, I do agree with it. So it actually says that, it also connects to a lot of answers like hidden right now. So it's also about how on for what you use AI for, right? So for certain things, don't resort to AI, right? So resort to AI where you spend a lot of time for unimportant tasks. So maybe automate those and save time. But rather for important things like brainstorming and coming up with solutions, maybe do actual team brainstorming rather than just resorting to AI. Yeah. Thank you.
Yeah, thanks, Gokul. There's one more question on Indian cultural fairness. In India, the text-to-image models play a very important role, and it's more challenging to evaluate all these things. Say we have different cultures, different beliefs, and different food-related things, right? So, is there a way in which you can evaluate cultural beliefs in India?
Yeah, that's a good point. I think specifically, not just India, there are a lot of like culturally diverse countries. In our analysis, we saw that some of the countries where there is a lot of cultural diversity, it's the data, the public data sets don't really reflect that. So that is firstly one of the key issues. And in terms of like highlighting these the gaps itself, it's important to develop human-centric approaches, because if you are going to develop a model-centric evaluation metric, that is, you just use a bigger model to evaluate your smaller model, that would not really solve the issue, because it's highly likely that, at least for the cultural domain, your bigger model is also not that capable. So it's important to sort of keep humans in the loop, and it's even more important to do it for the cultural domain.
Can I just add? I mean, there is an interesting observation that we made. So we actually asked, I forget, a variety of these model generation tools, image generation tools to generate pictures for Pongal, right? For whatever reason, a large fraction of the images generated had the Pongal pot floating in the air. I have no idea why. I mean, we had to basic. I mean, we could prompt it down to the ground, but by default, it didn't matter whether it was Google's or whether it was OpenAI's tool. The pot actually always seemed to be floating in there. I have no idea why these kinds of errors creep in, right? And it's yeah, a lot of work needs to be done in this way.
Yeah, thank you, Prof. And thank you, Nitish. I think the next question can go for Gokul. So in the responsible AI aspect, right? So there are a lot of research works that is getting published, and it's all about scoring their dataset models and different results that they are working on. And the point in the very recent case that is happening is that MedGemma paper has published some latest breakthrough, but it missed highlighting some important aspects of how it is performing against their own responsible AI principles. So any comments on it?
Yeah, sure. I was muted. Sorry. I can definitely give my thoughts. One thing to note is that the people who want to like talk only about their technical capabilities of the model are actually not showcasing their performance on the responsible AI principles as of now. So that's a common thing that is there. So the one thing is that the responsible AI awareness has not crept into all the teams that are there in a big organization, for instance. So it is still taking time for people to kind of learn this and get started on it by default. So the practice also in the research community has not reached such a level that all these people should actually do a responsible AI benchmarking as well while coming up with a paper, right? So the field still needs to progress in that way. And yeah, with respect to MedJama, maybe I can ask Nitish for comments, but this has been the practice, right? So the technical capabilities and the responsible AI principles seem to be like two directions right now. But we do really think that they should be merged. But I think it's going to take some time to see that in action. Yeah. Nitish, if you have anything to add.
Yeah, sure.
No, nothing much to
Sure.
add. I think that makes sense. I think like a lot of tech reports, if you see like Gemini tech report, or like some of the bigger releases, there is a responsibility AI section, but it's not really, I would say, as exhaustive as for the fairness community to sort of act on it. It's not exhaustive. So maybe there should be like a separate like responsibility checklist or something, like how like
Right.
conferences, there should be such releases for models too. But yeah, no other thoughts.
Yeah, thanks, Ritesh. I can see that there are two different questions by Dr. Aditi and Satyendra, but maybe I'll try to merge it together. In healthcare specifically, what are all the RAI principles that you can prioritize? And how do you think you can implement all these things, be it strategically or technically, into the AI solutions that you are going to develop?
Okay.
Anyone can take it up?
That's a great question. Well, I have not personally thought about prioritizing responsible AI principles, but I think considering that it's healthcare, one crucial priority is that, not mentioned in any of these tasks or anything. It's the task performance. right? So the first one is to take care that the tolerance level of the task itself is it up to the mark? That's the first thing that needs to be considered. The second thing to consider maybe things like uh, privacy and security aspects. Fairness also equally goes because we need a good disease diagnosis model to perform across all kinds of users and patients. So I think that's also one thing. And something that can be thought of prior to deployment is things like even explainability and interpretability kind of things, right? So maybe doctors can make sure whether the AI is making the predictions for the right reasons and things like that. So I personally don't have a priority, but I think all of these should be evaluated prior to actually taking it into the real world. So Nitish, if
Sure.
you have any thoughts, you can add.
Yeah, anything in terms of cultural diversity, Nitish, you can pitch.
No, I think in terms of like healthcare, I think the most important thing is like interpretability, and I think it is as a research field picking up. Like if you see like iClear or like just the recent ICML, interpretability was a big thing. It was like a big community like working on interpretability. So I think that's like a very important direction if you want your models to be robust. And even beyond the fairness issue, I think you want like explainable outputs so that you can like easily diagnose. So yeah, that's sort of my thought.
Sure, Nitish. Uh, One more question about the ethical obligations of companies and researchers who are developing and deploying these models in a culturally diverse environment. Right? Do you see that there are any ethical obligations for the developers and deployers?
Maybe Nitish.
Sorry, I didn't get the question. Ethical obligation for
Ethical
the
obligations of the companies and the researchers who are developing and deploying the AI models in a culturally diverse ecosystem or landscape, right? So, how do you what could be the ethical considerations that they
yeah,
should
yeah.
make note of?
Right, yeah, there is, I think, before every model release, there is sort of like safety checks, and there are, like safety filters on like most models that are released. So if you sort of like try to interact with these models in a very like offensive setting, you would have already like encountered the model just doesn't respond, or it just tells you, that's against the community guidelines. So that is like I think the way like model releases sort of make sure like no other offensive outputs come from these models. But again, these are not like ingrained to the model itself. There's like a separate safety filter. So I think that's the current approach to safety. But I think what we here are sort of interested in is like making the models itself aware, or making the models itself safe to give you like just the right response, or just to like steer you to like non-offensive conversations. That's the ideal scenario. Yeah.
Sure.
Can I push you, Nitish?
Yes.
No, I'm going to push Nitish. I'm getting something. So, how much of it, going back to the question, right? How much of it is ethical obligation, and how much of it is, regulatory or legal?
I mean, I'm not the best person to answer it, but at least I see from the safety
It's
point
not
of
fair to put you on spot. Yeah, we need 2 levels above you.
no, but it's a good point. I think at least what I've seen is there is a good amount of like when the model gets trained to the point it's released, there is I think a lot of legal and I think ethical checks, and I think that's sort of like the standard. But I wouldn't like sort of have more visibility into the exact process.
Yeah. I think this is a common question and last question to all of you. Is there any of the critical issues related to culture or fairness that is not outspoken so far, but that's existing still?
Well, I can think of, I mean, something not being discussed is it has been discussed, but maybe not been brought into this forum of responsible AI is the, I don't know, like digital access and inclusion kind of things. So that is far away from our efforts. So it needs to be enabled by infrastructure, a different infrastructure itself. So data not representing those people who are excluded from the system, and then making decisions only on those representations we have. Right. That could be a digital exclusion, solution exclusion for a lot of people that are out there. I hope that is being addressed to a certain extent, I can say, but still needs to go a long way. I'm sure Professor Ravi has some thoughts.
Yeah.
Well, I mean, I was read this article recently, kind of, the people are talking about how you have to be very aware of the cultural nuances of how people answer things, right? So, for example, somebody was saying in certain tribal populations, if people stay silent, it doesn't mean that the answer is no. You ask, do you have any condition about XYZ? And if they stay silent, it is that they would prefer not to talk about it to you, but doesn't mean that they don't have the condition. So there are all of these. So when you start actually getting these AI models to start interacting with people live, especially in more sensitive domains like healthcare and so on and so forth, you really have to be aware of the cultural nuances of how people interact and how people share information. And it is not just a question of what has gone into the training model, but these kinds of the interaction. There's a lot of HCI questions that come up, which when we talk about marginalized populations and other things, that has not happened so far, right? So I think that is a part of the conversation that really needs to happen, and I don't know if we are doing enough in that space. If you want to add something.
So, I mean, I actually agree. So there is a lot of things that we can maybe, I mean, the AI should basically know, or is there any way to find what are the assumptions based on which AI is currently working? That would be.
That's why we need more transparency, right? So
Yeah,
we
yeah.
talked about what kind
Sure.
of data the model is trained on, what kinds of conditions, and we also probably need to start thinking about, okay, what kind of interaction modalities the model is fine-tuned for, right? Maybe that also needs to be declared, and then we can have an understanding of it. But it's actually not easy. Especially in many contexts in India, a lot of these things are not even studied. We don't have enough
Right.
ethnographers who have gone out there and have looked at these and recorded these kinds of behaviors, right? So I think, yeah, a lot more work needs to be done. And it's not something you can just
Nitish?
upload to the AI. I think
Yeah.
we really need humans. These are some jobs which are not getting replaced by AI anytime soon. But
Sure. Nitish, any thoughts?
No, I think I agree with the comments, and I think one specific I would say, like, sort of at least now it's being spoken about in terms of safety, is like LLMs, ability to persuade you. Like, if you sort of like have a very, like 50-50 thought, like, what is, like, hey, like, Gemini, do you think this is a good idea? You would see that these models are really good at persuading, and that is something that is not very, like, measurable, because you think, what the model is doing something, it's like validating me, or it's, like, telling me what I want to hear. But that might not be the safest thing, it's in many cases, for instance. So there's, I think, one important aspect of safety that needs to be studied.
Sure. Totally agree. Yeah.
Yeah.
Nice point.
Thanks, everyone. So I think it's almost time. Is it fine if we can close the Q&A session?
Sure. Professor Ravi, you can.
Yeah.
Great.
Any last thoughts, Professor Ravi or Dr. Hemant?
no, I mean, I'm super thrilled that we had so many people actually show up for the CeRAI conversations, and I can thank Nitish for spending time with us. And I'll leave the last word to Hemant.
Yeah, I mean, really, really thrilled that we had such a great response. 500, definitely 500 participants, but I understand that on live stream there were at least 200 the last time I checked. I mean, that must have increased also. So we are very thankful to the participants, obviously, to the speakers and people who worked behind the scene to make it happen. And our communications team is collating the questions which are remained unanswered, as well as the ones which came on YouTube, and we will publish the answers, if not individually, but summary of answers of all the queries that got raised. Okay. Well, thank you very much. And of course, this is going to repeat with different themes every quarter. So wonderful. Everyone, have a great weekend. Thank you.
Thank you.
Thank you. Take care.
Thank you,
Thanks, everyone.
everyone. Keep watching this space for more and more events like this.